Another next topic is velocity analysis using instantaneous center method. Okay. So Rakasa taught velocity analysis through the relative velocity method or velocity triangle method, and this is another method we used, instantaneous center. And the first step in both cases are same. Next, other steps are not same. Okay. Now first we will look into what is an instantaneous center. Now before I define instantaneous center, you just should have a knowledge about this thing what I am going to say now. You consider a link. This is I think that this is a link AB such that it rotates about A. Okay, so A is the center of rotation and the point B is keep on moving in a circle. I'll show that circle. So this is the rotation of this link, and imagine that this is moving in clockwise direction. Then when you look, it is in clockwise direction when you look towards this. So that is this direction. Okay, like this direction, and then with the velocity, with the angular velocity omega, then what will be the tangential velocity or absolute velocity or linear velocity at this instant? What will be that you already thought in that other topic, but I am just again telling the same thing. This will be linear velocity will be tangential, right? Tangential to the path of rotation. Path of rotation is circle, and I will show that direction. This will be the direction of that linear velocity VB, that is perpendicular to the link that we already defined. Velocity is perpendicular to the link. Linear velocity is perpendicular to the link at any instant. Okay, and this is the circle of that rotation. Now this is clear, right? This is a velocity at this point, and but it is called VB because B is the point moving. Clear? A is not a fixed, not a moving point, that is fixed. We can also say this as VBA. VBA means B with respect to A. Velocity of B, please note, velocity of B with respect to A. And that is a usual usual representation of relative velocity. This case, I am neglecting that, ignoring that A. Why? Because that is a fixed point. Therefore, we don't have to consider, because the velocity of B is absolute velocity in this case, because A is fixed. Clear? That's why we can ignore that A and simply say VB. VB means velocity of B with refer to a fixed point or absolute velocity. These are the definition. The next thing, then what is VB in terms of omega? That also you should know. VB equal to omega into the radius of that circle, that is the radius of crank. Usually we say radius, or the length of this link, that is corresponding to the radius. So this AB into omega will be VB. That relation is important, please note this. I hope this is already known, but if you don't know, please note it is VB equal to AB into omega. This relation is required. Okay, then we'll move to the instantaneous center. Now you consider 2 points A and B. Okay, this is very simple. Just listen what I am telling and correspondingly see your video, then you will understand. Okay, and if you didn't understand, you repeat the same. Okay, we have 2 points A and B. So A moves in, suppose A moves in this direction and B moves in this direction. Okay, just imagine that A is moving in the given direction, B is moving in this given direction, VA and VB. Okay, now if A is suppose this is a rotation. Okay, if this is a rotation, where will be the center of rotation? Just think, if this is if A is rotating or B is rotating, where will be the center of rotation? Remember the previous slide. When we have center of rotation and the rotating direction, we draw the velocity. Now you do the reverse. Now we have the velocity. then where will be the center of location? The center will be a line perpendicular to this velocity, right? Center, if there is center, it will be on a line perpendicular to the velocity. So you draw that line, that is, you draw a perpendicular to VA at A, such that center will be at that line, somewhere in that line. Okay, this is a perpendicular to VA, and similarly you draw perpendicular to VB. Okay, now these perpendiculars are meeting at a point, common point. So this common point I will define as I, or instantaneous center of both A and B at this instant. Clear? So now we can say I is a point at this instant such that it is a center of rotation of both A and B. Clear? Simple. This is valid only for this instant. So this instant I is a center of rotation of A and B. So we can say I is instantaneous center of A and B. And the very next instant the center will change, because the very next instant this direction of VA will be changed. If it is a rotation, direction of VA will be changed and direction of VB will be changed. Then we have to find a new center. And this is the definition of instantaneous center. And the use of instantaneous center is the velocity analysis. I will come to the next slides. Okay. Now, so what relation can be written? What relation we can find from this? If this is so, what is the distance of corresponding to the radius or the distance, the length of link here? In case of A, if this is a center, IA will be the corresponding radius or length, and in case of B it will be IB. Now what we can say, if it is omega, if the angular velocity is omega equal to, otherwise VA equal to omega into IA, this distance. Similarly omega equal to, in case of B, VB equal to omega into IB. Okay, so this relation also you please note down. So draw this and note down this relation, also the definition. Clear? So this relation is required to solve problems. VA in terms of instantaneous center only. VA at this instant, always this instant is important. Okay, otherwise there is no use. This is only valid for an instant, because we are drawing, we are solving problems by drawing the space diagram at any instant. The method is that only. Okay, therefore that is important of instance. Okay, so VA equal to omega into IA, that is I is the center, so center to distance A, center to distance of that point A. Okay, IA, that is here. Similarly IB. Okay, now next is number of instantaneous centers in a mechanism. So number of instantaneous centers in a mechanism is given as n equal to, capital N equal to small n into n minus 1 by 2, where n is the number of links. Small n is a number of links and capital N is a number of instantaneous centers. So please note this. So in case of a 4-bar mechanism or 4-link mechanism, what will be the number of instantaneous center? 4 into 4 minus 1 by 2. It will be 6. Similarly, in a 6-bar mechanism or 6-link mechanism, what we can say, 6 into 5 by 2, that is 15. So in a 6-link mechanism we have 15 instantaneous center, and 4-link mechanism we have 6 instantaneous center. So we will start with the 4-link mechanism, then we will move to the 6-link mechanism, or so on. Now a theorem useful for analysis of instantaneous center or determine location of instantaneous center is Kennedy theorem. Okay, all these things also important, please note down. If 3 bodies move relative to each other, okay, this relative motion is important because in a mechanism there is completely relative motion. One link is moved relative to the other. That's why this theorem is important. If 3 bodies move relative to each other, they have 3 instantaneous centers, and lie on a straight line. Okay, this is a theorem. So the proof is not required. If anyone want the proof, they can ask me, then I will give. So that means if we have simply, if you think we have three bodies, 1, 2 and 3. Okay, 1 is a body, 2 is a body and 3 is a body, such that these motion are relative to each other. Then what we can say is there will be three instantaneous center, I1, I2 and I3. And these three center will be on a straight line. Okay, that is a theorem. That is, if I have a center, consider P, Q and R, 3 points. The P, Q and R, three bodies moving related to each other. If the instantaneous center of P is at this point and instantaneous center of R is this, then I can join, if I can join it with a straight line. So Q, the instantaneous center of Q will also be in the same line. That is a theorem. Okay, somewhere in the same line. It may not be here. It may be left to IP or right to IR, or in between this, but will be on the same straight line. This is the theorem. Clear? So this theorem is important for locating instantaneous center. Please note down this also. Then we have types of instantaneous centers. Okay, not types of, simply don't write types of centers. Types of instantaneous centers, or I centers you put. First one is fixed centers. Then we have permanent centers and neither fixed nor permanent. That is the third type. Or we can say we have primary and secondary centers. The first two constitute primary centers and the third one is a secondary center. So what is a fixed instantaneous center? Fixed instantaneous center means is actually a fixed center. If a point is fixed, that is a fixed instantaneous center. That corresponds to a fixed instantaneous center. That is in case of a 4-bar mechanism. We have two fixed points, right? We have a fixed link. That means we have two fixed points. Just imagine, right? So those two are fixed centers. Why it is fixed center? The point is fixed and point is not moving. Fixed means not moving, or we can say it is permanent and not moving. Clear? The next one is permanent centers. Permanent center means they are not fixed, but the point is permanent, or the center is permanent. Now you consider the same 4-bar mechanism. We are connecting crank with the coupler. Okay, so just imagine that we are connecting crank with coupler with a pin joint. So if crank is AB and coupler is BC, B is the point where we are connecting crank with the coupler. So that point B will correspond to a permanent instantaneous center. About what? About crank and coupler. And why? Because that point is, why is a permanent center? Because that point is not fixed, but the point is permanent. That means the point will be always B. That is the point where both links are joined. That is a pin joint. So the pin joint will be the same, but the position of pin joint will be changed. Clear? The position will be changed according to the motion. So we cannot say it is a fixed center, but the point, the pin joint will be same. Always the pin joint will be your instantaneous center. That is a permanent center. And third case, neither fixed nor permanent. That is a pure instantaneous center. That means that what we saw seen in the previous case, that is not fixed and not permanent. That means at some point instantaneous center will be at somewhere in a space, say at a point P. The next instant it will be at some other point in a space Q. So next instant it will be other point. Similarly, it keep on changing at each instant. So such centers are called neither fixed nor permanent, or secondary centers. Now next point. From this definition, what we can say is, if you are given with a mechanism to find or determine or locate the instantaneous centers of that mechanism, then by direct inspection you can locate both fixed center and permanent center. Right? Just think. You can direct inspection. We can locate both fixed and permanent center or primary centers, but you cannot locate The third one with the direct inspection that need some calculation or analysis. Okay, clear. Now we'll demonstrate with the 4-bar mechanism. That is the simplest mechanism. We have saddle crank mechanism and 4-bar mechanism. Now here this lecture we'll see about 4-bar mechanism. So in case of a 4-bar mechanism, we have 4 links. First is fixed link, second is crank, third is coupler, and 4 is your rocker, or sometimes it's the same as a crank, a rotating link. So the links are 1, 2, 3 and 4. So the number of links are 4. Then what will be the total number of instantaneous senders? It will be 6 that we already mentioned. We have n into n minus 1 by 2. So when you calculate, you will get 6. So there are 6 senders in a 4-bar mechanism. So what are those senders? So those senders are listed here. Just see. We have first fixed link. So fixed link have a sender with all other 3 links. Clear? That is, fixed link have sender with the crank. That is 1, 2. Don't think that fixed link, the link 1, whatever may be it may not be a fixed link. Yes, link 1 have sender with the link 2, 3 and 4. That is I12, I13, I14, 3 senders. Then similarly for all other links also. That is 2 have senders with 1, 3 and 4. So 1 is already mentioned. Therefore we'll start with 2, 3 and 2, 4. Then 3 also having 1, 2 and 4. So 1 is here, 2 is here, 4 is here. Then 4 also the same. So there will be total 6 senders, and this will be 6 sender. Okay. Note down. Now we will solve it for a 4-bar mechanism. We will see the position of those senders. Now this is considered a 4-bar mechanism, ABCD. So instead of that, I will mention this is ABCD, but I will mention in terms of 1 to 4 as a link. This is now points A, B, C and 4 points. Now instead of that, I will mention it as a links. So first link, we have link 1, link 2, link 3, link 4. Clear? Now where will be, we'll keep on locating each sender. Where will be I12? It is simple. The point join, it connects 1 and 2. I12. Okay. That is a direct inspection method. Where is I1, 2, 3? Joining 2 and 3. Where is 3, 4? Joining 3 and 4. Where is 1, 4? Joining 1 and 4. So these are our primary senders, and we located with the direct inspection. Clear? So how many are remaining? We have 2 more senders. They are I13 and I24. So these 2 senders are not fixed or permanent. They have to be located. So how will you locate that? Let us consider I13. How will you locate I13? For that, you have to consider Kennedy theorem. What Kennedy's theorem states, if there are 3 bodies, they have 3 senders, they will locate at in a straight line. So just remember that theorem. Then what we can say is, we have I12 and I23. So where will be I13? Just think I12, I23 and I13. These are the 3 senders corresponding to 1, 2 and 3 generally. Therefore, we have I12 here, I23 here. So where will be I13? Same line of this. Clear? We can also say if we combine 1, 3 and 4, bodies 1, 3 and 4, the instantaneous senders are 1, 3, 1, 4 and 3, 4. 1, 3, 1, 4 and 3, 4. Therefore, 1, 4 and 3, 4 we have here 1, 4, 3, 4, and a line joining 1, 4 and 3, 4 is already a link. So you join 1, 2 and 2, 3. Okay, this is a line joining 1, 2 and 2, 3 and 1, 3. Similarly, the another line 1 will join 1, 4. Another line will join 1, 4, 3, 4 and 1, 3. Clear? Now you got it. Okay, that is how we locate. That is, again I will explain. We have 3 bodies 1, 2 and 3. Therefore, the associated senders are 1, 2, 2, 3 and 1, 3. Therefore, what we can say is I13 will be a line joining I12 and I23. So this is this line. Similarly, we have another set of body 1, 3 and 4. So what we can say is I13, I14 and I34 will be on the same straight line. So you join I14 and 34 that already we located. So I13 will be on the same line only. So both lines are meeting at this point. That means there is no doubt that is your I13. Okay, this is how locate I13. Now next is I24. How will you locate I24? Now you consider you have to consider a combination of 2 4 with the other links. So you can consider 2 4 you have to locate. So you have to consider a three link combination, that is 1 2 4 and 2 3 4. Okay, you note down two combinations 1 2 4 2 3 4. So in case of 1 2 4, what are the centers? According to Kennedy theorem, 1 2 1 4 and 2 4. Clear? So here we have 1 2 and 1 4. So where will be 2 4? A line joining 1 2 and 1 4. So you draw a line with joining 1 2 and 1 4. Okay, I will show. The next is just imagine, are you drawing? I will explain. That's next animation order. Okay, now we have 1 2 3 and 3. Next is combination 2 3 4. Right. In case of 2 3 4, according to Kennedy theorem, we have instantaneous center 2 3 2 4 and 3 4. Clear? 2 3 3 4 and 2 4. Therefore 2 4 will be on a line joining 2 3 and 3 4. That is 2 3 is here, 3 4 is here. So you extend or join 2 3 and 3 4 and extend. Similarly, you join 1 4 and 1 2 is already joining is here, so you have to only extend it. So both will meet at a point. That will definitely your I24. This is how you have to locate all instantaneous centers. Clear? Now we located all instantaneous centers of a 4-bar mechanism. This is about location of instantaneous center. Then next, how will you find the velocity? How will you do for it for velocity analysis? How you can use it for velocity analysis? How will you use? I'll just give you a hint. This is a 4-bar mechanism. Okay. This relation is also important. That I will explain now. So. Okay, now you listen, we have a 4-bar mechanism. So remember your symbols A, B and C, D. A is this point, B is this point, C is this point and D is this point. Hope that is there in your book, A, B, C, D. Now usual case 4-bar mechanism, this point will be fixed and this point also will be fixed. So A is fixed and B is not fixed, C is not fixed. So B and C are not fixed, A and D are fixed. Now, which is your crank? Usually this 2 will be your crank. So as the crank rotates, B will move, right? C will also move. And what is your input then? Input is crank velocity. What is your output? Output will be rocker velocity. So imagine this is a crank rocker mechanism. So output will be rocker velocity. Or what is rocker velocity actually? You have 2 points in rocker, C and D. So D velocity is not the answer because D is a fixed point. So the velocity of C will be your rocker velocity, right? So we have two velocities, velocity B and velocity of C. So you will be given with the velocity of B or the enough data to determine the velocity of B. In all questions, you just check your relative velocity method questions. You have the same thing. So first step is same that I mentioned is because we have to find VB. First step is same in two aspects. One is you have to draw the space diagram. So first you have to draw the space diagram and you can also find the velocity, input velocity VB. Okay, so you'll get VB. Once you got VB, next is you are drawing all these instantaneous centers and you have to find VC, that is your objective. How will you find that? Using instantaneous center. Again you remember now we have I13. I13 is the instantaneous center of 3. Clear? this is instantaneous center of 3, and we have a link 3 having two endpoints B and C. So how will you apply that velocity relation? It is already here. BB divided by distance of B from center. What is the center at this instant? What is this at this instant? What is the center? I13. So VB by I13B will be equal to what? Omega 3. And this omega 3 will also equal to, other end you take VC divided by I13C, this distance. Okay. So this is equal to omega of BC or 3. This is the relation you have to use. So when you use this relation, how will you find? BB is you already found. I13B you have to measure. You are using scale. You're supposed to draw this, and then only you can continue. So then you measure this I13B, write it. I13C also you can measure, write it. Then the only unknown will be VC. So by substituting this first two set, this equation, we can find VC. Or also if you take the ratio, you will find omega of BC. Clear? This is how you have to solve for velocity. Clear? And there will be a problem you have to do in the same way. You have to do it and check. Okay. And one more thing I will add with this. Okay, last thing. Why we choose I13? Because why you can ask me, why can we choose I24 or any other link? What is the importance of I13? That is because the link under our consideration is link 3. Clear? Because we have point B. Point B is common to both 2 and 3. And what you have to find is velocity of point C. And C is common to both 4 and 3. That means B and C are points on 3. So if you know, then we have to consider only link 3 and point B and point C. So when you consider a link alone 3, the instantaneous center we can choose is I13 only, or if you choose 3 alone, you can choose the instantaneous center I13 only, because I13 means what? The instantaneous center of 3 with respect to fixed center. Clear? That's therefore it is absolute. So what your result, these velocities will be absolute velocity. That's why we are choosing I13. Clear? I13 means this is a center of 3 with respect to 1 at this instant. 1 is fixed. 1 means it is a fixed link. Okay. So this is related. This will give you absolute velocity. So we have absolute velocity only, and what we have to find is also absolute velocity, not any relative velocity. Therefore, we are using I13. Other methods we can use this also, but the relation will be not simple and there will be different relation. But you have to always use this relation. That means if your link, and simple thing, if your link under consideration is named as link 5, then you have to locate I15 and use this equation. Similarly, if your link under consideration is link 6, you have to find I16 only. For solving the link 6, you have to find I16 only. Solving a link 6 means you have to solve the one endpoint, velocity of one end of the link and other end of the link. So clear? So if you have heard that doubt, that also probably clear. So that's all for this class, except this problem. So if you have any doubt, you can ask, and this also will be included in your first periodical exam. Only 4-bar mechanism and instantaneous centers, and this 4-bar mechanism only. No other mechanisms are included. Only this thing is included. So this problem you should solve in a pin joint mechanism as shown in figure, that you can skip because all data are given, so you can draw it. So it is given the data AB, BC, CD and AD, and also the inclination given. So you can draw what will be your fixed link will be AD, it's not given as fixed link, but in this case you take AD as fixed link, AB as crank. Okay, so AD, you draw 600 mm, take a suitable scale and draw 600 mm, AD, mark it as AD, then take 60-degree inclination and draw 300 mm to represent AB. Then BC and CD. From B you take compass, you take 360 mm corresponding scale, draw an arc. From D also take 360 mm, draw an arc. Both will meet at a point C. You join BC and CD. So your mechanism or space diagram is ready. Then you do the same thing and find I13 and I24 is not required because you have to find only one instantaneous center to solve this. Then you don't know how to draw other instantaneous center. Only the required instantaneous center you draw. So hope you need only I13 because the question is crank rotates uniformly at 100 rpm. Question is locate all instantaneous center. Then you have to locate all instantaneous center. Okay, and find the angular velocity of link BC. So angular velocity of link BC you have to find. The same similar points are same only in this question. Not the diagram or orientation will not be same. So this relation will be same only. This relation you can use. So you have to locate I13 and find VB. You have to find initially with this data. AB rotates at 100 rpm. Then you will find BC and do it and put it in your book. Okay. So any other further information I will pass you to WhatsApp group. Okay. Thank you.